So, first of all, before I start this presentation, I wanted to ask if you can raise hand to how many of you have heard the word blockchain or briefly know what it is? Okay, how many? Okay, good. How many of you have heard the word Bitcoin? I think a bit more. Okay, so let's start first of all. What is a Bitcoin for the people that don't know? So Bitcoin, it's a digital asset. It's a cryptocurrency that we can use to send money and do transactions between different systems. More specifically, it's really mysterious and funny, the fact that Bitcoin started from a paper that had an anonymous author. And the name on that paper was a Japanese name like Satomi Nagatomo, something like that. But Satoshi, sorry. Thanks, Dimitris, for correcting me always. And he was describing a way, after the financial crisis in US, he was describing a way that people could make transactions without relying on a central bank. So that was the idea, that we want a fully decentralized way of doing transactions. And the number of those bitcoins, it's finite, so it's limited. And people, in order to use them, they need to buy them from the available bitcoins that are online. So recently, the price of Bitcoin has grown exponentially, let's say. It has grown too much. So, like 3 years ago, you could buy with 2,000 Bitcoins just 1 or 2 pizzas. But now, 1 Bitcoin costs like 2,000. This is the yesterday price, like $2,500. So nobody knows where exactly it's going. So let's go now into more details, like what was the initial problem and why Bitcoin came. So Bitcoin was trying to solve this problem where every bank, every user, in order to do transactions, they have to use a central bank. So Alice, if Alice wants to send money to Bob, this transaction has to go to bank has to approve that, and finally bank keeps some records where it says that Bob has this amount of money. Now, so here we have only one database, as we can see, the bank, and all the users are the clients. So what Bitcoin wants to do is that every user should have their own database. And this means that everyone can participate in this network, and you don't need special hardware for that network to participate in. More specifically, we see, like, if I say it with simple words, it's like I have my notebook and I write down, like, Leslie sending money to Mike today. When I have that notebook, then Leslie should have the same notebook, and David and everyone. So I say, hey, I make an update, so everybody should listen to me. I send this new notebook, this new information to notebook. Then Leslie looks at his notebook and says, yeah, I agree, this makes sense. David, I agree, this makes sense. So a kind of consensus mechanism works internally that was solving quite a lot of problems that other systems weren't solving before. So in theory, it's simple, like database, a copy. But the interesting part here is, though, that all these transactions are encrypted. So we are using cryptography to encrypt and verify all those operations on top of Bitcoin, and meaning that also one of the good properties is that if this guy, for example, drops out, doesn't participate anymore, still the system, as far as there are a specific number of users participating, is going to always achieve a final state. Also, what this system guarantees that if someone tries to do some fraud, and for example, if I say that I send to Leslie, hey, I want to send this money to Davide, and I send another message, hey, I want to send this money to this guy and I don't have the money, finally the system will try to catch those kind of transactions. So now very quickly into details. So how does the Bitcoin and the blockchain, so the blockchain is a protocol underneath the Bitcoin. But I will go and explain that a bit later. So how does it work internally? How I described, you have a notebook and you have versions coming into that notebook. And you are using, every notebook uses some kind of data structure which are called Merkle trees. And those Merkle trees internally are using some hashing mechanism where you take A and B, you hash it. It's like a binary tree, but on top of it you have hashes. The property of this is that you can query it fast, and that you can guarantee that if I change the history at some point, I cannot reach the other guys that are in front in one other block, because I need to calculate all those hashes. There are, these are internal details mostly, and we can discuss more if somebody is interested to explain all these internal details. And the way that users, something important, want to participate in this network is achieved by giving them some money when they participate, meaning that think about it as a puzzle. So they say, hey, this puzzle, the user that manages, this puzzle has to be solved. The user that manages to solve it first will get some, like 25 Bitcoin currently, and it's going to decrease later. Now, what I'm describing now is a distributed network that is used mainly for transactions, like send money from this guy to this guy. But looking at this technology, a lot of people thought, hey, this is really cool. What if not only doing transaction, I can have a Turing complete language on it? Like, I will explain that. So this guy, who is 23 years old right now, a Canadian-Russian, Vitalik Buterin, if I'm correct, Dimitri, introduced Ethereum. So Ethereum is the other version of blockchain, which is not only, it doesn't only have user accounts that do transactions, but it introduces smart contracts. And smart contracts are like a virtual machine that you can run some code. Yes, and Ethereum has also persistent storage. So Ethereum now comes with another coin, which is called Ether. So the idea is that when you have a coin, in order to use the smart contract or these virtual machines, you have to pay some money. So you have to buy these Ethers. And right now, the price of Ethereum is also going very... Here, you can see that it's going up all the time. I don't know if this is like trading strategies or if this is the real value. But until now, a lot of companies as well, are participating in this, like Microsoft, Google, I don't know Google, but IBM, and they are building this kind of financial groups to do research in this area. So Ethereum, it's exactly the same as Bitcoin, but imagine that we have it's not exactly the same, but it's an extension of Bitcoin, where instead of every user having a notebook, every user has a notebook of virtual machines. So here, you can run its code, write some code, and you know that from the moment you publish it to all the network, the other guy will take the code that you wrote and will try to run it again. So we have from one state A to one state B, and this is where the transaction function, the code that you write in this virtual machine. If you have any questions during my presentation, you can interrupt me. It's okay. Thank you. So, if we go... Yes? What is the process about the smart contract or smart contract? How does it go? So, yes?
Yeah, so how does it get
So, think that you have a version of blockchain. You can write some new piece of code on it, right? So you publish that on your blockchain version. First of all, everybody has to take that contract, so you publish that contract. Now, if somebody wants to use, he just sends a transaction. It's like a function call in a programming language. So when you send a transaction, then this smart contract runs. So, but when you send the transaction, you have to pay some money. So this is where the money aspect comes. Internally now, it's exactly the same blockchain that we're safe, but instead of just transactions before, we have this virtual machine that has storage, has some smart contract, and has some balancing. And the virtual machine has some properties that we will discuss a bit more later, which is that when you write the code, you cannot change it after you publish it. So this is a very big problem right now, because it's almost impossible not to write code-free, bug-free code. So programs write the contracts, and after some point, somebody finds a bug that they can exploit, and they cannot update this contract. So they can lose money. Now, the two versions that I'm explaining are the public available blockchain. Like everybody can use them right now, can download the wallet, can play with those, and can write some smart contracts, can make money, probably can mine. Dimitris has some, like 2 Ether already mined, and some Bitcoins. I haven't any yet because I came a bit later the state. So, but finance now and all those companies, they find it cool, like the architecture of Bitcoin and Ethereum. But what they are more interested is in the business aspect. So they are interested more in the blockchain, in the architecture that is used underneath. And if I would categorize, the blockchain, we have the public blockchain, which is available to anyone, and it's fully decentralized. So the banks and these are not interested that much in this. So we are going to the other use cases, which is private blockchains. Private blockchains is like banks want to use blockchain and advertise that they are using blockchain currently. So they say, okay, let's do proof of concept internally. So they have different departments inside, and they say, okay, how can I use blockchain if one department doesn't trust each other? So it's a bit weird to hear that in the same organization departments don't trust each other, but this is happening in a lot of them. So we were working in a project with Data Spartan on how to find some use cases internally where they had some. We cannot discuss many detail, but where they had some inconsistencies and they were thinking about using blockchain. And then is a hybrid blockchain, which is like banks want to have their own system, and they want to know, they want to do, like Bank A wants to do business with Bank B and Bank C, and they say, okay, let's have a blockchain, but it's going to be only us participating in this blockchain. Now, so this is another chart showing the differences. Like we have Ethereum and Bitcoin in the public one, and from the private one and hybrid one, I would say it's the most popular is the Hyperledger, and the other one is Corta and some other version. This is a huge ecosystem right now of available new startups building their own version of blockchain, trying to get money for funding. They are saying that they are solving a particular problem. I don't believe most of them, but anyway, it is very innovative. And here, Hyperledger, for example, which is this hybrid version of blockchain, they want to build a network where all these financial institutions or organizations can participate, but it's not available to, and they build some channels in between them, meaning that we may have a public-private blockchain between us, but we may have even more private inside this private blockchain, meaning that peer 1 and peer 2 can build their own internal network inside that network. That is what they are trying to achieve. All those except for Bitcoin and Ethereum, all those products are, in alpha or beta stages. Probably Ethereum now it's like first release, so they are still evolving quite a lot. Hyperledger. Another blockchain system that we work with is BigchainDB. So the problem of blockchain, as I said, is that everybody has to have a copy of it. So these guys from Germany say that we need a system that is more scalable and that can, have thousands of transactions on this. So they introduced a hybrid version of blockchain, which is, in practice, it's just MongoDB, and on top they have these cryptographic hashes. So it's not exactly blockchain. People started in the beginning criticizing this kind of system, like hybrid blockchains, meaning that, hey, this is not a blockchain, I can do this in a database, or why should we care about this kind of products? You are not following the correct path. But we see that in finance they like these kind of different products, that they see that they can solve some problems that other people outside their circle don't know. And there is a very, very big trend right now in blockchain, like a lot of funding from Europe, from a lot of countries investing, 2,500 patents at least until right now, and a lot of money. Like UCL has a blockchain center. They got some money recently. We have collaborations with China, where they also invest a lot of money in blockchain, Hong Kong, all this. Most of the people, I don't know if they really know what they want to do with blockchain, but they pay. And the main categories of investments right now, it's like blockchain used for infrastructure, for exchanges, for financial services. There are some mining pools that you can get more, you have more probability of getting some bitcoins, payment, as we said, and wallet. And here is, I think this was from Bloomberg, like what they vision about blockchain is that currently we are still in the state of proof of concept. So we take some blockchain product, blockchain-like product, try it internally, see if it solves a particular use case, and before we go and build more stable networks. Also, we have identified that usually they don't say, hey, I have this problem. Can blockchain solve this? They say, hey, I have blockchain. Can I solve a problem? Which is a bit, So they are trying to sell the name mostly. Use cases of blockchain, shared repository, like all the banks can have, no, not banks necessarily, organizations like companies that manage diamonds can use blockchain to store the properties of those diamonds, and if somebody buys it, they can know where exactly this diamond came from, what was the price. So you have this kind of workflow. You have multiple writers use cases that they think, and majority think that they are going to be used in the future, where all those banks have their own users. They can do a lot of transactions with them, but eventually they have a network that they can use to do transactions between them and have a stable state. Also, blockchain is very useful when you don't trust someone. So, for example, Bitcoin was very popular because you were exchanging money with people that you don't know, so drug dealers and this kind of people were using it. Or now recently the hack that was very popular NHS in England, at least the hospital, they were saying pay 300 Bitcoin to the hackers to, yeah. And also, like, banks want blockchain because they think that finally they can save a lot of money by excluding the intermediaries. Like when Bank A wants to reconciliate some trades with Bank B, they have someone in the middle that just does this process, and they have to pay money. So they think if we have the same network, we don't need this guy. Or probably we don't need lawyers if we're using smart contracts. That's good. And transaction dependencies, like you have, especially in smart contracts, you can have more, clever ways. Like if David gets a payment from someone else, make that payment automatically to someone else, and a lot of layer of transaction. And for financial use cases, more specifically, it's like this trade reconciliation and transparency between different departments, that they want to use a property that you cannot change the blockchain. So if you write something in that database, nobody can change it without being approved. So one particular problem is that if someone does an operation in a bank or in a company, and later he regrets about that, he wants probably to delete it. But with blockchain, you cannot do this because it provides one property that other databases provide, but not in this guarantee. Like the admin of database has full power. If he wants to delete a record, he can delete the log. Nobody will understand. But with the blockchain, they cannot do this. And then it's for compliance. They think that it can be used. So we have a common network of bank and compliance. So whatever transaction the bank does, the compliance can also monitor, and we solve this kind of problem. We have for individual crowdfunding, like very easily now you see a lot of startups that they introduce their own coin on top of Ethereum or Bitcoin, Ethereum mostly. And they say, hey, I need funding to start this blockchain new project, and we are 5 guys, and we will do this cool stuff. So I will issue this asset, which is 1,000 assets, for example. And I'm selling it in this price if you want to buy it. And users very easily can buy that asset, hoping that in the future the price of this asset is going to be higher. So the company, the startup, gets very easily funding. An example was recently a startup which came from the guys of Ethereum wants to do predictive betting on top of Ethereum, meaning that you will have some smart contract saying that, I don't know, Kim Jong-un will attack Japan, I don't know, in this time. So people can say yes or no, and they can bet on top of it, because this will happen automatically. You just send your money there, and it knows that this guy betted there. So they are trying to use this for predictive analytics as well, seeing what the population feels about events, and And this particular use case and the platform that they are trying to build up was very popular, and they sold 10% of their company for, I don't know, like 100 million or quite a lot. I'm not sure about the figure. So now, like smart contract. So I said Bitcoin was only for transactions. Smart contract now is you have a programming language, you write a Turing programming language, and you write some code on it. Meaning that practically whatever you can code in your PC, in theory you can code it in a smart contract. So you can have for example, when you want to buy a house or sell a house, you can write, what guarantees the one should provide and what guarantees the other should provide. And if something in the future happens, you can take your money back, or this kind of things. Of course, there are a lot of issues to be solved, like how do you get this information from outside? How do you guarantee that So that's the main problem, how to get information from outside. And there's a lot of research, and other companies are trying to integrate blockchain with this kind of services. Okay, so smart contracts. Can we write a smart contract? Can somebody write a smart contract right now? Yeah, of course. You just need to spend some time. It's not. They are trying to build tools. It's still new, but they are building a lot of tools on top of it. And they are providing, the most popular language is Solidity code, which is a kind of JavaScript language, where you can write your contract, you can compile it in some bytecode, and you can just send it to the network. And whoever uses that contract has to pay some money. But you can make money from the contract. Think about it, that this piece of code can keep money on it and can do some operation based on the transaction that happened there. So, for example, I described we were doing an analysis, like we scrapped all the smart contracts right now available on Ethereum, and try to categorize and see what kind of things people are trying to do right now. This is for the public blockchain. The use cases for the private are going to be most probably easy. But because users can play with it, so we saw token asset ownership. So you build a contract, as I said before, where whoever transacts and pays some amount, you can store in a mapping, like this is the balance of this person for this asset. Funny thing was this smart contract that it was quite popular, which is called high yield investment programs, meaning that those are Ponzi scheme in other way. Like you say that if you call the contract, it will keep your money, hoping that if someone else calls the contract, you will take your money with some profit. So, it's just a Ponzi, and if you are the last one and no one else is sending transactions, you lose your money, but it's being used. Or you can also you can use it for notary reasons, because whatever you store there cannot be deleted, as we said, so you can provide to someone very easy proof of a document existing. So you can take a document, you can hash it, and you store the hash in some blockchain, in some smart contract. And you can prove later that, look, this document was created there, I have the proof. It can be used for simple games as well. Like you can program a simple roulette, so you see all the code of the roulette. And when you call it, randomly you can win or lose, but you will play directly and you will lose or win ethers. Also betting in future events, and there are also other, smart contracts used as libraries, like you can write a library, fast one, to do some math operations, so whoever uses that library has to pay some small amount of money. Okay, so one of the big problems of smart contract is that programming smart contract and being sure about that they are secure, it's difficult because of this property. You need a property that you say, hey, whatever you write in this smart contract, we have to trust. So this is our, judge, or this is our goat. But at some later point, somebody may have found an error that he can exploit that contract. So programmers cannot patch it. And as I will show, we have this kind of cases. So this is the most popular version of smart contract that was very critical for Ethereum because they almost stopped as a company, but as a product. But eventually it managed to fix this, and they are becoming so popular now. So they built a smart contract which was crowdfunding. So people were putting their money there, and eventually they would take based on some investment that a consortium would decide about this money, would take some money back. But there was an error in this smart contract, and some other programmer managed to find it. So the smart contract gathered a lot of money, like, I don't know, like millions of pounds, whatever.
$36 million.
$36 million, yeah, I have. Yeah. I have Dimitris here, like my assistant, who will talk later. And so a programmer managed to write a nice smart contract that he was sending transactions there, and he was using a property of reentrancy. So again, the smart contract was calling his contract, and then again calling it back. So he was managing to take money slowly from it. And he stopped it until 30%. So not to take all the money, to leave some, to make people still want this version of blockchain. So there was a very big debate there. So what do we do? Do we accept this version, or we stop the blockchain here, go in the past, and which is called the version fork, it's called, and we try to do the same transactions for the rest of it without this contract. So initially, what the developers of Ethereum did is they hacked the hacker. So they hacked the smart contract that was hacking them so as to stop it stealing money. Eventually they had, I think they have two versions of, some people said, no, we should trust this version of blockchain because it's not our fault that somebody wrote a faulty contract. This is what we should trust. And also the guy anonymously that wrote this contract used a lawyer as well to say that, hey, nowhere, I didn't find anywhere saying something that I cannot use smart contracts to take money from an account. You say that I can use smart contracts in whichever possible way I want. So he wanted to sue the Ethereum developers because they stopped his transaction. So it's very new that people still, there is a lot of legacy issues. People start playing with it. The price is going up, and it's quite interesting to see. And other smart contracts have had these problems, like where you have your money, somebody can use some code, steal all your money. And even now, there are possibly contracts that we don't know yet what vulnerability they have, so we can probably exploit them at some point. So from our, analysis that we did on smart contract, it's like currently in Ethereum there are 2 million accounts, meaning 2 million accounts you can have both smart contracts and user accounts. And all those accounts have in total 92 million of ethers. The number of ethers that contracts have, so a contract has money at some point, is 10 million, so it's 1/10, almost 1/9. And note that when you have a smart contract, the owner that creates a smart contract can write the code in such a way that he can take money back. He has to write the rules there. Now, what are the challenges, though? As I showed to you before, I showed you only this, which is the source code of this Solidity language. So, someone can write this contract. So, if somebody wants to use it, he has to understand JavaScript or this kind of language. Let's say, okay, he understands, he's a programmer, but not necessarily. When you publish it, you don't publish the source code. You publish the bytecode. So, analyzing, we found this problem, analyzing and understanding smart contracts, it's quite difficult to, you can do analysis, of course, like symbolic execution and this kind of stuff in bytecode, but only few smart contracts that are available right now have this source code provided. I guess they are using their contracts for their users and they know exactly, maybe they show it there. But there are a lot of mostly research-oriented problems, like how do you identify that this source code is with this bytecode and all these security problems. So I will try to write a very small smart contract right now, which is so we have a puzzle, let's say, and we want to solve it from time to time. So we say we can write this kind of smart contract, meaning that I will, when I initially create the contract, I set the puzzle. Puzzle probably should have some more code or should interact with some external event. And I give a reward of 100 if there's whoever solves it. And I write two functions. One which says submit solution, and I can verify it with the puzzle. And one which says update the reward that the owner of this smart contract wrote. So you can see for example, they can say, hey, this is the URL of the puzzle. You can solve it down, and you probably need to send your hash of that solution back, or the result. You send it there. So when you send means I do a transaction to submit my solution, and if it's correct, you get the money back. Yeah, so this is exactly what we show here. So this guy found the solution, sent a transaction, and he submitted the solution, gets his reward back. Now let's go to the second. This example was from a paper making smart contracts smartest, where they found this kind of vulnerabilities. So let's see now if I am not that good contract owner and I want to get my puzzles for free. What can I do? So I am ready to send a transaction like the owner, which means update a reward. This transaction can be done only by me, but I don't send it yet. So what I do is I'm waiting for someone to send his solution. It destroyed a bit, this conversion destroyed a bit my animation. But anyway, so the user sends his solution and the code executes probably here. And before the other transaction happens, the owner sends a new transaction which is update reward. But not always, but in many cases, he can make the reward 0 before the transaction is executed. And this is a problem with concurrency and the fact that blockchain is so new and they have this kind of problems that they have to solve at some point. They are trying to solve, but right now this is a real use case. So he submits his solutions. So this is called transaction ordering dependency. Because what happens is that every user sends the transactions, and the miner gets all those transactions, and he can reorder those transactions because of the protocol. So if the transaction of updating the balance was before the sending, the owner would have the reward, and he wouldn't pay anything. So there are a lot of problems and bugs like this. Yes, it can be even by coincidence or it can be malicious. Yeah, so that's all. Quick, I don't know what time is it.
Thank you, Michael. So, any more questions? Yes, Paco.
Are you seeing any integrations yet with code repositories? It seems like this would be very natural to put into GitHub or Bitbucket to have bounties for PRs.
Sorry, can you repeat the questions? I didn't hear the first part.
My question is, are you seeing any integration of distributed ledger yet with code repositories, public code repositories?
Okay.
Like GitHub and Bitbucket. It seems like this would be very natural for putting out bounties to extend features or fix non-bugs.
Yes, like all those guys are open source most of the time, so when they develop. But using blockchain for a particular code repository use case, I haven't found right now. Which could be, we can discuss it even more and think about, how to integrate this. But there are a lot of projects, and Ethereum and Bitcoin community has a lot of programmers currently working on that and trying to find all these bugs. Yes.
I have a question. As the owner can make some changes to a contract by issuing a special transaction that is not available to other people.
No. The owner can do something special only if he writes in code. So you can check the address that is doing the transaction. So you can have an if statement saying if the contract knows where it receives the transaction from and the address. So you can, and the owner has a unique public address, private public cryptography that there is. So he can have an if statement saying he knows if the address matches to the owner, he can add some additional functionality. But in theory, I, as a user, before I use this contract, I should check the smart contract. And I should check that, hey, this guy is trying to do something dodgy. So I will not trust this smart contract. So you are using blockchain to solve the problem of trust. I don't trust someone, but I will trust the code that somebody has written. And if I can see that code, it's amazing and I can understand it. So
the update transaction could be done by anyone?
No.
But you can't because...
Yes, sorry. Yes.
You can't have it without control. Okay. But then, as one contract is also very complete and has base for memory.
Yes, exactly.
Then the owner could update the contract and make it execute any other bytecode that might be embedded in the contract.
Yes. But you can see all the, you can do, it's Turing complete. You can store, when you store something, it's usually permanent. You have memory, you have storage, we didn't talk about a lot of things like gas, for how long you can run a smart contract, which gas is you have to pay, and eventually, you cannot write a while loop that it's infinite, because think about it, that everyone has to run this while loop. So you have to pay some cost. And if that limit exceeds, the transaction throws an error and it reverts. So the user loses the money because user or the smart contract.
Wow.
David.
Yeah. Did you see any connection with code verification? Like automatic code verification? Because it makes sense if the context can have bugs.
Yes.
So to expand this, it makes sense to try to verify the code automatically.
Yes, there is a lot of research like symbolic execution, and they are trying to use some proof solvers, but I think it's quite mature, and nobody has solved this solution. And I don't know how exactly, because it's not my area, but I think they need a lot of testing and a lot of running, so they cannot, particularly when you have once a smart contract there, every time you want to use, you have to pay money. You can try it in a test blockchain probably, but it's not a solved problem. There is a lot of research. Yes.
But I don't know if it has a bug. It would be nice to have a tool that actually verifies that code.
Yes, but there doesn't exist anything. Yes. But that is in programming language a problem, like the testing that you are trying to use, and all this random testing. Yeah, and I don't think all the language can prove that it's bug-free or something. Maybe Haskell or this kind of functional private. I think Haskell and some other languages.
Ricardo, you were...
Sorry, yes.
It's more a kind of ethical question rather than technical one. Among the contracts, you mentioned Ponzi schemes.
Yes.
And Ponzi schemes are often considered as a fraudulent contracts.
Yes.
In fact, Carlo Ponzi was in jail.
Yes.
Fortunately for him, because there are thousands of people that want to lynch him.
Yes.
But what about in this case? Is it considered as a regular contract or what?
Yes, it's considered as a regular. First of all, there is no regulation right now in blockchain because it's distributed across the world and nobody can control it. So if you want, you can use a smart contract. You can use it anonymously. You can have private key, nobody can see. In theory, yeah, okay. It's like a game, a betting game. You say, I will put my money hoping that somebody else will put as well. And I will take his money. So it's kind of played. The owner of the smart contract is gaining some transaction, and eventually he can take some of this money back. And there are a lot of smart contracts like this. But people use it just for fun or take some money. That is the coolest thing. It's that you have code that can make you money. Okay. Always code makes us money. Most of us are developers, but not in this. Okay.
Leslie?
So I just had a question, which was basically that, currently you're blockchain expert in one bank, and you have worked with blockchain in another bank prior to that. So from your knowledge in financial discipline and everything that they're doing at the moment, what do you think that the financial institutions in general want to do with blockchain?
So I don't know if you heard in the back, but Leslie was asking what will the financial institution do with the blockchain and what I have seen. So currently they are still experimenting and they don't know what particular problem to solve. So it's exactly this case. They say, wow, blockchain is cool, we can use it, we can do this. Okay, what problem are we trying to solve? And they say, okay, let's try to solve blockchain with this particular problem. And I have a lot of discussion, and like the first meeting I went with Leslie said to me, hey, let's go for a blockchain project. So they want to do blockchain. We went in a meeting, and they're saying, yeah, we want to use blockchain for this particular project. And they say, why blockchain? Yeah, because it's cool and it can solve the problem. No, but this is internal database, traditional distributed database can solve this. And then we had an argument with Leslie, not argument, like, hey, you said to me to work on blockchain, but the guys don't have use case for blockchain. So, yeah, but don't say them that we don't want to work on blockchain, was, the business part. But eventually we found the use case that was solving this trust issue internally, And but banks eventually, I think, will progress into this. They will not have this kind of public blockchains. They are not that much interested. I believe that also they want to intervene somehow. Like they cannot trust the code 100%, saying that this is what the code does. I will trust it because of regulation, probably because of, this kind of use cases with hacking, hospitals. So it's still I don't see it right now happening. They will try to use it to see how it works, and eventually, maybe in 10 years or 20 years, we have something. They are also saying that we will use blockchain for, automobile, for almost everything, But still, it's very mature, very new.
Okay, more questions? All right, so thank you, Micah.
You're welcome.